Good afternoon. Hey, Steve, how are you, buddy?
Doing great. How you doing? Good to hear your voice.
Welcome, man. We appreciate all you guys hanging with us this afternoon. We're excited. When we get together and talk about digital dentures, we get very excited. So I'll get us started. Dr. Wagner's going to talk about the clinical side of this workflow, and he's doing some wonderful things there. And he'll mention some materials and some lab steps that at the second half of the program, I'll talk about all the materials that we're using and some of the way the things are handled at the lab and back and forth. But just to introduce ourselves, I'll start and then turn it over to Steve. Jimmy Stegall started working in a dental lab in '79. There were 8 of us and grew it to about 135 employees in 3 locations. Did about 100 crowns a day and 100 dentures a day at our heyday. But we started small, so I understand small lab and big lab. And a part of my role at the lab over 38 years was to help and teach docs. So I was in offices like Steve's almost on a daily basis, guiding through impressions and shades and implant work. And so I've learned a lot on his side of the business just by helping and supporting, and that's what we are here as labs, is to help and support. So all that just says, I've seen some things and I can share those experiences, and that's why I'm here, and that's the only reason I'm here. So clearly I'm not from Pennsylvania, or I'm not from New Mexico. I'm from, I tried to hide the accent once, but it's hopeless. So Granddaddy said, just go with it. So I'm Jimmy, and here's Steve. We'll let him get started.
Yeah, hi, I'm Steve. I'm a prosthodontist down in Albuquerque, New Mexico. I'm in my 42nd year of practice. Trained at USC Dental School, went to MD Anderson Cancer Center for my prosthetic training. So I'm a maxillofacial prosthodontist, but I really describe myself as a denture maker. And I've been dabbling in digital probably since about 2010, 2011. The practice now is almost fully transitioned to making digital removable prostheses. A couple different techniques, one of them which I'll talk to you about today. But the whole idea is that we'll really look at what advantages we have with digital, why we should go to digital, and what workflows should you use on the clinical side that will make it worthwhile for you. So that's going to be my next 20, 25 minutes. We'll have a question and answer afterwards, so feel free to send in any little questions, and Jimmy will send them to me. We'll discuss them. But this is really just, think of this as a hands-on, practical talk from a guy that's working day-to-day in the shop. So I'm enthused, and I can't wait to show you what I'm doing. So let's go on with my slides. What I'm going to be talking about specifically is digitally fabricated dentures and why you would want to make them. The dentures that I learned to make, that you learned to make, my father learned to make in 1950, really are all the same. The techniques that were developed by Carl Boucher, Muller DeVan, these people in the 50s, were really the techniques that we're learning in 2020 in school. And the techniques were great then, but they would produce a wonderful product. But I think now the effort to make it and the monies that can be generated from it don't equal each other. They don't match anymore. And so the idea is that we've made wonderful dentures for 70 years, but this is the time to change. And there's reasons for it. A couple of them that come to mind is that with the technique that we learned, if we're lucky, it's 4 to 5 clinical visits. And usually those visits are 30 minutes, 45 minutes, an hour. That's very expensive. If you think of it, the cost of doing a denture or minute to minute in the office is very expensive. And so if we could shorten that time, it's important. The old techniques just takes too long. The dentures that we made don't have a great fit. We always had to compensate for shrinkage in production. And we accepted it. That was great. If a denture almost fit, we were thrilled. But they never really intimately fit like the new ones do. And it was difficult to duplicate a denture. I mean, if you had to make another denture for a patient, you started at point 1. Well, those are all disadvantages that we have to deal with. Denture making is a craft. And that craft takes time to learn. And if you're just coming out of school, That's not good. You don't have the craft developed. You've only done a couple of dentures in school. It'll take you a long time before you learn it, so you could be disappointed pretty quickly. Schools don't have the time available to teach it. Enough said. There's only so much time in a dental school curriculum, and there's a lot of things to learn. So that's really cost denture making over probably the last 20 years. And there are fewer technicians trained to make a denture. The skill of doing it passed down from teacher to student, technician to technician. There just aren't that many technicians left to make dentures at the quantities that we need to make in today's environment. So it's important that another technique be developed, digital, that would allow for technicians that are really trained in a broad scope to be able to make a denture also. And I think probably the biggest one for me day to day is the stresses caused by making implant-based dentures. The stresses in the denture itself causes the denture to break. The materials just aren't strong enough for today's implant-based dentures. So those are the things we need to deal with. And why digital? I guess I explained it. We're going to cut down time. I'm going to be able to show you how to go from a 5-appointment to a 3-appointment technique, which will save you hundreds of dollars in chair time. So time is a big deal. That's what comes with digital. As I was inferring, it costs about $5 to $7 a minute to run your practice, maybe even higher in some communities. And so if you could cut out 60 minutes of time and do that over and over again every time you make a denture, that's going to add up, and it really adds up fast. Fit is a big thing. Up till now, up till digital, we've had 8% shrinkage in a base when it polymerizes. You've been distorted. Your base is distorted by 8% from the get-go. We put a post-palatal seal in it. We do all sorts of tricks to try to make it work better. Technicians have techniques that will limit that shrinkage to a minimum, but it could never be zero. Well, now it's getting pretty close to it. This is an illustration of a denture that's been scanned and compared to the master cast, to the master impression. And if you look at the ones that were done with the pack and press method, you'll notice that the green, which represents extreme accuracy, is limited. There's certain areas that are very accurate, but certain areas that are not, and that's due from the shrinkage. Well, with these new techniques, either milled or printed, the denture really fits like a crown. There's an intimate fit, and that makes a big difference in the way the denture will be retained, and makes a big difference in the way in post-op visits. You have less post-op visit with digital. And again, those are expensive, so it's important that you that this is a big deal. Now, the way a denture fits is not by suction. I mean, you think it's suction, you hear suction every once in a while, but really it's the intimate contact of the tissue to the intaglio surface of the denture. The closer that is, the stronger the adhesive and cohesive forces for retention will be created. We don't want any air to get underneath it, and that's where the sort of the suction sense comes from. If you get air underneath it, that bond breaks. So that's why we need a good seal. But the importance of fit can't be overemphasized. It's really one of the primary reasons that makes digital denture making a pleasure. And strength. An old denture, an analog denture, has only so much strength that it can obtain with the material. A typical example would be a split of a maxillary denture down the midline with a denture opposing natural teeth, or over a locator, something like that. If we could increase the strength of the materials, and that's what digital does in both milled and printed dentures, that's a game changer. I mean, if you look at these dentures, they're beautiful, they're strong, they look familiar to you based on what you're used to. So it's not like you have to reinvent the wheel mentally. It's just a little change that I'm going to demonstrate today that will allow you to make probably, I think, the digital dentures today we've never surpassed what we can offer the patient today. And that comes from a lot of different companies, either milled or printed. But this is really the renaissance of denture making, and this is the time to really grab a hold of it. So what I'm going to describe is what's called typically the reference denture now. The idea goes back a long ways, but the point is we're going to use the patient's existing denture to make a final denture. It's this workflow. Take the dentures, make impressions, make interocclusal records, send that to the lab. They make a try-in this case, a monolithic denture. That's modified, confirmed, and then that's rescanned and a final denture is printed. We're talking about 3 30-minute appointments here, not 3 hour-and-a-half appointments. I want you to go fast, and I'm going to show you ways to do it. But you should be able to deliver that final denture in that 30-minute, maybe even 3 weeks, 1 week apart. And that's very appealing to the patient. So the first appointment. The first thing to do is to decide whether you should use the patient's existing denture as a model. In other words, look at the denture. This is one I made out of a clips, probably 2000, maybe around 2000. The patient liked it. It's worn out. It's stained. Probably the teeth are worn a bit. So, but it looks like it has pretty good general outlines. It's not grotesque. The patient didn't hate it. Never make a new denture based on a denture that they hate. So this is probably a good candidate. And this would probably be a good candidate for a good patient to work on. The denture is unattractive. The vertical dimension of occlusion is probably pretty close. Aesthetics could definitely be improved. And when I looked at the denture, I realized that it had pretty good extensions. Typically, a lot of these old dentures will be short. They'll either be short over the tuberosities or short over the pads. And so we got to look at them. And this is what I've done here. I've taken this denture and I've decided it was a little short in the back. So I added a resin material. You could add compound, whatever you want to do. But take that denture, modify it by adding a little material, probably into the tuberosities. A lot of times they're short there, into the pad, a little short there, maybe a little short on the flanges. But just sort of examine it. Don't take an old denture that's short and expect to make a beautiful new denture just by making an impression. You have to modify it. So impression making. Now, for me, impression making means using a rapid set polyvinyl siloxane. You can actually use any impression material you want, from irreversible hydrocolloid all the way up to silicones, polyether, all of the materials that you're familiar with. I particularly use a product from Dentsply. It's called Aquasil, and it's Aquasil Fast Set. And the reason why I like it is it sets in 2.5 minutes versus 4 or 5 minutes. And it also is a material that has the right consistencies for border molding and impression making. I'll show you that. First thing you do, no matter what material you're going to use, is you paint an adhesive to the denture. Some people talk about, well, I don't want to put an adhesive in a denture that I'm going to send the patient out to within a few hours. But I found if you don't put adhesive in it, it just makes scanning a lot of problems magnify. So put a little adhesive in it. And then what I do is I use a material called Aquasil Ultra Plus Fast Set Rigid. There's 4 consistencies to the material. This is the rigid. And I found that to be the best thing I can use for border molding. So here I am border molding the denture. I do it all at once. I basically fill the denture, fill the borders a bit with this rigid, and put it in the patient's mouth. Now, what I do is I like to position it by holding it. You could position it by having the patient bite down into the denture, and that might be reasonable in some cases, but a lot of times that'll kick the dentures loose if there's any inaccuracies in the occlusion. So I find it's better to hold it down, have the patient go through border molding motions, move their lips, move their tongue. I have them lick their lips. I push down on the denture to activate the masseter muscles to create that masseteric notch. I have them put a tongue over on one side, tongue over the other, and then I let them sit, in this case, for 2.5 minutes. So they're sitting with that lower in place. And this is what you end up with. You can see that I'm starting to develop some pretty interesting anatomy on the lingual. I'm covering the pads, but you see show-throughs in this material. And now this is where making an impression in a denture differs from making an impression in a custom tray. In a custom tray, you don't want your denture to, you don't want the tray to show through your materials. That's going to cause some hot spots or pressure. In a denture, you need to have some hot spots. You need to have show through to make sure your denture is completely seated. If you don't, the denture could come up and forward, and I mean, on the top, it could come down and forward and really ruin the aesthetics and placement of those maxillary anterior teeth. So it's important that you see those show throughs. The other thing is never, at least this is me talking, and this is me from experience, never grind on a denture you didn't make. In other words, don't relieve those areas, because, and I've had it happen to me, you grind on the patient's old denture, somehow they end up not liking you, they're dissatisfied, and that old denture doesn't fit. I mean, the example for me that I had was a patient that came in, this must be 20, 25 years ago. The patient came in, a friend of a friend, I was gonna adjust a denture that I didn't make. It was some simple thing on a tooth, like polishing the edge of a tooth. And I put the denture in the patient's mouth, and he did that thing where he points to the upper denture, opens his mouth, and then waits dramatically to have that upper denture just ooze down. Hey doc, this denture doesn't fit now. Look, and then he does it again. You know it should fit. I mean, I was conned. And what I ended up doing was remaking the guy's denture for free. That was the lesson that I learned. Never touch somebody else's denture. So here's my final impression, and I did this in a lower viscosity material. But you can still see the show throughs, but you can start to see the detail of the intaglio base of the final denture. Ideally, my impression is going to be a prescription to the technician on where I want my flanges, how thick I want them, and their length. So this should be ideally what the denture will look like. It's not quite, but it's a start. Now, what you need to do is trim off any excess that has come over the occlusal surface that will interfere with interocclusal record later on. So you clean that off. Now, what we're going to do is do exactly the same thing on the top, and then we're going to take an interocclusal record. And I do that with a polyvinyl siloxane of some sort. That could be Blue Moose, it could be Regiseal, that's what I'm using here, but whatever you like to use. It's important to use a lot of it because you want those two, the maxillary and mandibular denture, to connect together, and so they'll be easier to scan here in a few minutes. So that's what this looks like. This is my final product after appointment 1. Now in my office, I'm going to scan this with an intraoral scanner, a prime scan, whatever you have. But there are now techniques where your assistant can actually scan this denture, the intaglio surface of the maxilla, the intaglio of the mandible, the cameo surface, the occlusal surface of both dentures, and a buccal bite, the interocclusal joint, interocclusal record. And you scan those, and then you can return the denture back to the patient. If you don't have a scanner, you could make arrangements prior to this where the local lab can run over, grab the denture, get it scanned, get it back to the patient in an hour or two. That works too. But the idea is that you're going to get the patient's denture back appointment 1. Now, Jimmy's going to talk a lot more about this monolithic try-in, but this is what's popular now because they're very easy to print or mill. And it's a trial denture that you're going to use appointment 2, and it is the color of your final denture, the color of the teeth, and it fits just like the final denture. It's a printed, accurate representation of your impression, and it has the interocclusal record that you developed before. So this is what's real popular now. This is what I'm going to show you how to use. So we're going to take that monolithic denture. We're going to talk about how that's made in a bit, but I'm going to take it now and take it to my second appointment, my second 30 minutes. And what you do is try that in. Look at it, kind of get a sense of what you like, don't like, and start to evaluate that, having the patient participate, the traditional things you would do with a try-in. Now, the problem with these monolithic try-ins is you can't move teeth. You've got to be able to communicate with the technician in a new way. You can't change a tooth and have the patient represent that. You've got to describe that change. And I do it 3 ways. One with photos, one with notes, and one marking the monolithic denture itself. So photos, this is a big thing now for a lot of technicians. More photos, the better. Any camera, iPhone, high-end DSLR, whatever you have, just start taking photos. Take videos if you can. I mean, an iPhone video as the patient speaks is just a great communication tool to the technician. And the more images you can give that technician, the better. They love it. I mean, here it is in my interocclusal record. I've evaluated it. I can communicate that to the tech. I personally use a Fox plane to communicate the occlusal plane to the technician. I just put a little Regiseal on the Fox plane, put it up against the occlusal plane of the monolithic denture, take a picture. This one looks pretty good. This one looks pretty good. So I take these pictures quickly, or my dental assistant does, again, just for a communication tool. I mean, if it's off, that'll demonstrate us that'll mean something to them. Then I take my occlusion, evaluate it, and even photograph that, maybe adjust it. At this point, you want to adjust it and to get it to fit the best you can. But again, take a photo. Then I send off notes. I'm not a great note writer, but I am now. So I'll kind of communicate the changes that I want to make in the laboratory prescription. And I guess the new way of doing laboratory prescription is to actually mark the monolithic try-in. I do it with a Sharpie. In this case, I might be communicating that I'd like the midline to be shifted, maybe rotating a lateral. I've got marks where I'm going to be changing the occlusal plane. I may be shortening a tooth, filling in to the gingiva. These are the things that might be reiterated in your writings, but a picture tip is 1,000 words, so it's important to just mark these up, and that can go very quickly. Now, you can do something else with the monolithic try-in that you really can't do any other way, and that's to send the patient home with it. You could send it home with just the white denture itself, the tooth-colored denture, and let them evaluate it and see what they like over time. That's terrific. Or you could, in this case, somebody added a gingival color to the monolithic denture, sent them home. They can be evaluated both aesthetics, function, and chewing. The big thing is you don't want to make this so good because they might leave you and not get the final product. So you really want to make sure that you select the patients you send these home with. Now, I did send this patient home, and they didn't like the fit of the lower. So I made a new impression, a closed mouth impression in the lower that would give me a little bit more retention. The patient responded positively. The other thing is that any changes you make, let's say you're shortening the flange of the maxilla, which is a typical change, anything you do to the monolithic denture will be inherited into the final product. So, so when the patient comes in, you don't have to repeat these changes. They're all done in the monolithic denture. All right, so that now goes back to the lab. The lab will rescan it, make those changes that you want, and then reflect this in the final product. So when your third appointment, I'm saying is going to be 30 minutes too, but a lot of times it's a lot faster than that. You just don't have to adjust these things as much. You put it in, maybe you put a little adhesive in just to get it started, put it in maxilla and mandible, have the patient close down on some cotton rolls for 5 minutes, make minor adjustments to the occlusion, and you're done. I mean, here's an example of a printed denture with actually with bonded teeth. The bonds are extremely strong, but that's a beautiful denture. I think that's a terrific thing that you could offer, and you can offer it consistently. So what I do is just put in the mouth, put some cotton rolls between their mouth, let them sit 5 minutes. That seems to make a big difference. They seat well. I have them check their occlusion, and off we go. So this is the occlusion that I got. It's I try to do lingualized in this case, and it is pretty accurate, but I needed a few adjustments. But I mean, to be honest with you, this is a great way to start. And you end up with a patient that's happy, thrilled with their work. If they want a duplicate, you could actually sell them a duplicate reduced rate. If they lose the denture, you could immediately make it. You just press a button, basically. So this is a wonderful service. Remember our lady that we had before? I mean, suddenly she has a beautiful denture. She's made whole again. And it's a denture that you can feel proud of. It's strong. You know you could make another if you wanted to 5 years down the line. It's really a wonderful service. So that's kind of what I've got to talk about right now.
I'm going to dig a little deeper into the materials and the actual workflow between the office and the doc, and probably fill in a little more of these gaps and questions and try to answer some of those as well as we go. So we'll start with some of the things that Dr. Wagner has mentioned. Right? Why do we even do a digital denture? And, he hit on the fit, and I agree 200%. There's no doubt that we get a better intimacy of acrylic to tissue when we do it digitally. And that's the reason for that is that we've taken out a lot of the nuances with traditional denture fabrication steps, right? There's a stone model or a scanning impression, but there's no investing and there's no packing and there's no processing. We're either milling or printing directly from a digital file. So we've taken out the steps that cause a lot of the shrinkage and expansion issues. And, so that's a big deal. The fit is going to be better right off the bat. One thing that people, I think key on a lot, and I think it's one of the most important parts, is that when you deliver a denture today and the patient calls tomorrow and said, something happened to it, what do we have to do? And you always in the past say, we've got to start over. But with this, you don't. The lab has the digital record on file, and it's simply pulling up the file and running it back through the printer or the mill. So you're going to see all those other benefits chairside. Steve mentioned how much time you're saving. And I didn't do many 5-step dentures. Most of ours was 6 to 8 because of the multiple try-ins. And this also takes a lot of that out. So your patient experience is going to be better. And wouldn't it be nice to do dentures and do them fun again, right? So, kind of give you just a little history, right? If we've been making dentures digitally, right, on a computer screen for several years, at least 5 to 8 years. But you got to take it to analog, right? You got to have something to put in the patient's mouth. So how do we get there? We started with milling, right? And that's good because what we did was we take the traditional acrylics like Lucitone 199 and manufacture them in a solid puck that was already cured, that was manufactured in a way there was no porosity. So it was super strong, no more shrinkage, none of that. So, and we just milled it from a 1-to-1 file. So we had a really, really good fit. And that's the kind of the way we were going. And their early systems were designed that we would mill a base and we would bond the same denture teeth we had always used into that base. And, you know, I always thought that was a little bit of a funny way to take something so technology advanced, so digital oriented. And the last thing we did was to glue a tooth in a hole. And, but that chemistry has been figured out in a huge way, so much that we just don't see tooth pop out anymore. But that's where we started, was with milled. Now, if you would look at it in my lab, we did a lot of these, right? But if you look at that, there's a lot of pucks in those pans. And just do the math. Every puck is a 3 to 4 hour process, right? So that's, 2 weeks worth of milling, running a couple of milling machines nonstop, or I've got to have so many milling machines to do that many. So it's not a very production oriented system. It's okay if you're doing small quantities, and the cost is a little bit more, but not a lot. The labor savings with the tooth setup and all that makes it worthwhile, but that's just not a productive oriented way to do dentures efficiently. It just takes too long. And so anytime we look at technology in the dental lab, we don't want to go backwards, right? I want to be able to do things as fast as I've always done it, as good as I've always done it, and hopefully we do it better. So milled, while good, just didn't give us the efficiency that we wanted. So printing obviously was the way everybody wanted to go. Additive technology printing versus subtractive technology, which is milling. Additive is so much better, right? There's no waste. Everything that we pour into a printer, if it's not printed into a solid piece, we can pour it back in the bottle and use it later. And so there's absolutely no waste to deal with. There's no excess like in a puck. So we came out with, our companies came out with what I call Gen 1 materials, and everybody's got excited, including me, because now we have something we can print pretty quickly that looks kind of like what we've done. It wasn't as ideal, and it's not quite as strong as what we've had in the past, but it was a great first step, and it gave us a good transition into printing technology. It gave us a denture that was good for a temporary or a transitional denture, but it just wasn't as near as strong as what we were doing with traditional processes or with milling. So time passed, and now we're into what I call generation 2. And the only one in this category is the Lucitone digital print, which we'll key on today. Lucitone digital print is the strongest, most aesthetic, easiest to use material out there. It gives us a denture that in the end looks like dentures that we're familiar with, and it has the wear resistance and strength and even greater fracture resistance than we've ever had. And it's simple for the lab to do. So labs can actually do this more efficiently than traditional. So what I see around the country is that most labs are going to charge about the same as they charge for their traditional standard or slightly premium denture. It's not economy denture. This is certainly a premium process. I want to run through the materials pretty quick just to give you an idea of how the system works, because it is so exciting. And from a 40-year lab guy, I get so thrilled to see, dentures move to a point where we got excited about zirconia some years ago. And I think this is going to have the impact in removable that zirconia had on fixed. The heart of the system is the Lucitone digital print. Now, it's not 199. It is entirely new chemistry, but it is a resin, right? Comes in 5 shades. A simple bottle, you pour it in the printer. It's designed and engineered with the carbon printer. We'll talk about the carbon printer a little bit, but just know, guys, that it is the best 3D printer out there today, not only in the quality and speed, but also in the support, which is a big deal with CAD/CAM equipment in the labs today. So 2 hours, we can print 8 to 12 dentures in this printer. That's pretty exciting. ISO high impact standards, a number that we've all lived with forever and ever when we talk about denture based strength, right? The bar is 900. If you don't have a denture base that's 900 ISO high impact, then you really don't have a strong denture base, right? And so 199, just give you a reference, is around 1200. This material, once it gets in the mouth, when it's about 90 to 98 degrees, it doubles that. It gets close to 3,000. These are joules per meter squared. So this is what it takes to fracture this material. So twice the strength of what we are used to using is a pretty exciting premise for me, right? I think about all the overdentures and locators and thin pallets that have broken in the past, and having a material that's this easy and looks this good and this strong. So it's pretty exciting. You can go YouTube, all these things about how strong they are, but Conrad and his team at Absolute Dental did one of the best I've ever seen. Not sure why the video isn't printing, but so we see dogs chewing them up. We drop them in sinks. We run over them with trucks, and they don't break, right? They just are extremely strong. I saw Dr. Cooper drop it out of a 3-story building. So this is a denture you can literally throw in the sink, throw against the wall, throw on the floor, and it will not fracture. I have seen a couple break. Anything, I guess, can break. But one of the cool things about it, I've never, ever seen a tooth pop out of these dentures, no matter what people have done crazy to them. So got no problems with the strength whatsoever. All the shades that you're used to, if you're used to using Lucitone acrylics, exactly the same shade. So it's just a different material and a different bottle, a different method. But at the end, the upper and lower set of dentures, I'd be hard pressed to understand or notice or recognize that it was a printed denture. It looks pretty much exactly like what we've had before. Simply pour and print. Most other 3D printed resins, you have to mix or heat or keep in an agitator or on a roller all the time. This one, the chemistry is mixed, it stays mixed, and you literally pour it into the plate and go. Technicians love to finish this. It's a very dense material. It finishes a lot like PMMA or composite resins. So it finishes in about half the time. I can polish and finish one of these down in about 5 to 10 minutes. So that's kind of the heart, the pink resin that we print in the carbon printer. The second part, and I get this question a lot, is the teeth. Why did you go with a carded tooth? Why wouldn't Dentsply figure out a way to print the teeth as well? And I would just say that technology is being developed. Nobody really has invented a bottle of tooth material that you can pour in a printer and print, and it looked near as good as what we're used to seeing in a carded tooth. Now, there are some materials that we can buy in a disc that we can mill out an arch of teeth that looks pretty close to denture teeth, but it doesn't have the occlusal durability as carded teeth. So Dentsply and Carbon, after looking at this a lot of different ways, decided to go, this is the best way to go. This is what we know. These teeth that were developed for the Lucitone denture are made exactly like our portrait line of teeth, which have lifetime warranty against wear or cracking or fading. These teeth are strong and they look really good. It's a new set of teeth, a new line of teeth, because they're already designed on the back to fit in these dentures. These are going to be bonded into pockets that were designed in the printed base to fit exactly. So it's kind of like a Lego block assembly. I'll show you that later, but we use denture teeth because we know what we get. Right, we're going to get a denture that we're used to. The try-in material, Steve's already mentioned. We'll talk about it a little bit more as we go, but it comes in 6 Vita shades. We're familiar with that, and it is a mindset change, right? We pour it in the printer and print it just like we print the bases, and it's just a monolithic version of our design denture in the computer. Now, the beauty of it is it's going to give us a lot more data, right? It's what I call the test drive denture. The patient can take it home and wear it and eat with it and whatever. So we get back the information that we need to cut down on the number of try-ins. They polish up really nice. And like we showed, you can put pink on them to make them look a little better. But think of it as like a crown and bridge temporary, right? We send patients out with a crown and bridge temporary in a form or fashion and for a reason. And this is more like that. There's nothing wrong with wax try-ins, and we'll still use them, but we gain a lot more advantages with the printed try-in. The last step is the assembly of the denture, and there's a fuse process. The chemistry was developed to really get a good bond between tooth and base. It's called fuse for a reason, because it's not gluing something in a hole. It is literally fusing the tooth and the base together. So the middle bottle you see there is the fuse material, and it foundationally is made just like the base material. So it literally is a fuse. So we bond the teeth into the base using a little tack light, and then it goes in this curing unit for about half an hour, about 26 minutes to get its final cure under both light and heat. And the denture is ready to finish after that point. So it's a very fast process. All told, it's going to save the lab an hour to 2 hours, depending on the processes that they do. So let's go through the lab workflow quickly just to give you an idea how the dentures are made and put together, right? We've got to start with the design, right? We're doing things digitally. So like Steve mentioned, we're going to take impressions, or we're going to take impressions in dentures, or we're going to take traditional bite rims, and we're going to scan all those things in to create a digital version of your model. And on that digital version, we're going to design a denture with the middle screen, right? And then we're going to move that design over to an output device like a carbon printer. printer. So we can start with a scanner, the box scanner at the lab, or like Steve uses, the intraoral scanner in the office to capture this data. That is just a scanner. The work is done on the computer screen to get the teeth set in the space that we have. And then once we've got it designed, we go to the output. So just a couple of screenshots of how the tech designs, right? Just like we did traditionally, right? We've got to decide where the occlusion goes. We've got to mark the anatomical landmarks to help us know where teeth goes. And we're just telling the computer these things, right? So those little handles that you see is marking the retromolar pad and the cuspid on the lower. And what that's going to do is that's going to draw Pound's triangle, which tells the computer exactly where to put the lower teeth. We're going to tell it how far to put the borders out, right? Like Steve mentioned, he'll make specific requests on how he likes his periphery to look. And we use this design tool to get it exactly like he wants it. Then we pull in the library of teeth we want. We set them in place, right? And we choose the mold just like we've always choose the mold, right? We look at a mold chart. We make some measurements. We determine which tooth looks the best or fits this patient. We put it on the screen digitally, right? And then we move it around. So, guys, I don't think my videos are showing, so we'll skip through that. Not a problem. Now, with Steve's reference denture, right? So we have the dentures that we're going to scan. We have the bite, and that purple that you see on that design screen is actually an overlay of the patient's dentures. The white that you see are actual my virtual denture teeth being set. So what easier, what better way for a technician to be able to set teeth than to have occlusal records and the contour and shape of teeth that Steve has already said, the patient's pretty happy with this occlusal plane. The teeth are a little worn and stained, so we just need to make a better looking denture with better acrylic. I have the perfect guide to do the setup virtually. So I think it's exciting. I've done cases like this where, the denture teeth are really worn down, but the patient kind of loved her occlusal plane. We just use that information to establish our occlusal plane and then just pick the teeth and set them to add the length that they needed back from the occlusal wear. Technicians have the ability to design the digital wax up any way they want. They can put all the anatomical features like cervical rolls or root prominences anywhere, anyhow. Some of the softwares do this automated, but technicians always have these really cool digital waxing tools to create this for you. So it's still doing exactly what we've always done. We're just doing it with different tools. Right? Here's a tech that uses a stylus and a pad to do it by drawing it. And it's great to be in this world. Right. So we're creating dentures virtually, right? I just showed you some screenshots that were from the 3Shape software, but the upper left is the InLab software. The lower left is the exocad software. These are just all digital tools to get us to the end game, which is a really, really good fitting denture, right? And that's where we're going. So we've designed it in a piece of software. We're ready to go to an output device, and that could be a mill, or we're going to spend time today talking about the printer. Right? I love the Carbon workflow. It's cloud-based. I take that design denture, I upload it to the Carbon software, I orient it, I nest it, I put the supports on it. The software calculates how much material I need, and I just push print, push go, right? And then after it's printed in 2 hours, we take it out, we clean it up. So here's 4 try-ins that we've designed. We've loaded into the Carbon printer, and 2 hours later, they're ready to remove and clean up and send back to the doc for try-in. So, what's different? Steve mentioned this, right? The multiple number of times that patients come back because the dentures don't fit or that bothers them, right? And this is just a funny way to look at it, right? Sometimes I've been in many operatories where you just really want to hand the denture to the patient. Say, okay, you do it. And my granddaddy was guilty of this in a big way. So I'd love to change that, right? I'd love to come up with a way that we can cut this down for you and for us so we don't have to reset so many times or readjust. So I think digital gives us that in a big way. And I think this new way to look at try-ins is certainly the best way to get there, right? If we can use a try-in step and method that cuts down on later appointments, then we really ought to take a good hard look at it. We're going to continue to do traditional try-ins. I think there's always going to be a dentist and a patient that has a need for traditional try-ins. But what we want to get away from, and I've been many a denture delivery where we've handed the wax dentures, put them in the patient's mouth, handed them a mirror, or asked them to go over to the mirror and say, okay, what do you like? What do you don't like? You tell us what you want, we'll change it. And you see this look quite often, right? This confused look. It's because we have too many choices. They don't quite know how to answer those questions. And so I try to simplify the try-ins, right? Just ask simple questions. Is it too light, too dark, too long, too short? But wax try-ins will always be here, right? There's always going to be patients that really need to see the final aesthetics before we go, right? And having the ability to move the teeth is certainly some advantages. But I have been in many cases where we've done 4 or 5 or 6 wax try-ins to try to appease the patient, and then went and processed the dentures and delivered it, and something was wrong again. So there's no guarantee that a wax try-in any number of times, but it does give us, the multiple chances to do that. I think there's a place for this, and I think there's a place for the printed try-in. And I think it's not the topic for today. There might be a place for something in the middle, right? Something coolly called the Wagner try-in, where we print a base, we cut the 6 anterior off, and we put 6 anterior teeth in wax. For another time. The digital try-in is really the thing that excites me the most. And I know it's a mindset change. We've all got to get our heads around how they look. And the patient's got to get their head around how they look, but it gives us so much more accurate information to move to the next step, right? Test drive, take home. And Dr. Wagner showed earlier about marking and adjusting and reducing and adding to these things to get the communication to the lab about the changes that you need. What I tell folks all the time, though, is think about these. This is your second appointment with the patient. You're going to put these in, and depending on how the reference denture impression looked, these are going to be the best custom tray and bite rims you've ever used. They're going to give you a ton more ability to get an accurate bite and an accurate impression. I would almost think about moving away from pink base plate and letting this kind of be my go-to base plate. But Dr. Wagner mentioned photographs. That's always helpful, but marks, drawings, words, pictures is what the lab guy needs to know, right? What to move on this temporary try-in, because what he's going to do, we're going to scan that try-in denture, and that scan that we do of that try-in denture, we're going to pick up the impression wash that Dr. Wagner put in it. We're going to pick the black marks up, any adjustments that he made. We're going to layer that back onto our screen and reset our new denture to match those changes, right? So my mindset is that I'm moving away from this and using these try-ins as my new custom tray. Right. And so when I send this to the doc, I'm asking for a new impression wash if it needs to be, any adjustments and a bite registration. And from that information, I'll go straight to final. And I think we'll be very, very close, and we'll cut down all these appointments. So we've done that, right? Dr. Wagner's done his try-in, patients taking it home for 3 days, 3 weeks, whatever. They've come back, maybe an impression wash, maybe some modifications. So now it's time for me to put it back in, right? I'm going to put that into my scanner, and I'm going to adjust the design. So what you're looking at here, the pink and the white are my setup. The gold is the layering scan of that try-in, right? So I can see where the teeth exactly are, where they need to be, right? Of course, the impression wash gave me the new intaglio. So we adjust the design, and we're ready to print, right? So now I have a virtual final denture, but I've got to turn it into an analog version. So all I really do is export the STL. I pour the loose tone digital print into the carbon printer, and I push go. I love this printer. I'm sorry the videos aren't working to show you how cool it really is, but it's a game changer in the lab space. Once it comes out of that printer, we do what's called post-processing. And all that is just cleaning up the printed parts and then assembling the denture teeth and doing the final cure. Support removal and cleaning is super, super easy, right? The carbon guys have really made this a joy. No more digging out a flask, no more worry about breaking or cracking, right? No more getting stone embedded in acrylic. These come out clean. We just snap the supports off. We go over to an ultrasonic to clean the excess resin off, and we're ready to put the teeth in. We pull out our selected mold of teeth. Like I said earlier, they fit in those sockets intimately. It's almost like a Lego block. And then we go to the curing unit. After we assemble the teeth, and we basically tack them into place with that bonding resin, and then they go into this curing unit for 26 minutes for its final cure. Cure under light and heat. And after that, we finish and polish like we traditionally do. There's nothing different with what we use or how we do it. Traditional carbides, instruments, traditional rag wheels and pumice and polish. And it just takes about half the time because it's a much denser, smoother material. And we've done most of the festooning and designing in the design side, so we don't have to do a lot of anatomy work here with the burr. So it's just finish and polish a little bit. Questions usually come up, can I repair them? Absolutely. We use the same materials we lute the teeth in to repair cracks or bubbles or replace teeth. Easy, 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 very fast. And we can reline it traditionally. We could put it in the jig press and reline it with a pourable acrylic, or we could pull the denture up with a reline wash impression, layer that in, and reprint a new base. Multiple choices, multiple options, right? And I believe it's all about options, guys. I don't believe that one system, one material has all the answers. I think it's great that we have all these cool options, but this is about the best thing going today. So that's the lab workflow, right? And hopefully, y'all get an idea of the dentures. You have the ability to make as anatomical or creative as you want to get as a lab guy, right? You have all these molds of teeth. You've got all the tools you need to create the different wax ups. And thanks again to Kate, the designer at Absolute Dental Lab in North Carolina. That denture on the left is just a gorgeous setup, right? It's just a beautiful work of art. So the technicians have all those tools with them to be able to do that. So, before we go back to the questions, let me just summarize what Dr. Wagner and I have talked about. And so you'll have a kind of a end game about what this workflow looks like. So you start with a couple of dentures, right? And you put impression wash in it, you put a bite registration material in it, and you send that to the lab, and they send it back to you in an hour. You certainly could take it back to your lab and duplicate it, right? And do the wash and the duplications and send that to the lab, and they'll put it in a box and scan it. Or, like Dr. Wagner, you can take your impression wand and you can scan the inside of that denture. You can scan the buccal surface of that denture and send that file to the lab to do the setup for try-in. Now, remember, when you're using an intraoral wand to scan a denture impression to get a new setup, you only want to scan the inside, the borders, and down the buccal side to the occlusal edge of the teeth. You don't want to scan the palate or the tongue side because we need it open, what I call a virtual open impression, so that we can treat it as an impression in the software. If you scan it 360, we do that when we're going to do a copy denture. So another good advantage to digitally printed dentures, if the patient has a denture that they absolutely positively love and you just want to get an exact duplicate of that denture, then yes, we do a 360 scan with the intraoral scanner and just tell the lab to duplicate it. We have the software and tools to do that. So once we take these scans, we design a printed try-in, we send it out, patient wears it for a while, new wash, new impression, new bite, markings, goes back to the lab, and the lab adjusts it. So here's the workflow, all right? 3 appointments. You start by taking a denture wash and a bite with the existing dentures. I think that's the easiest way. Statistics tell us that somewhere between 80 and 90% of the patients that sit in our chairs wanting a set of dentures already have a set of dentures. And so let's start with that. And the lab's going to scan that, design that, send you a try-in. You're going to do that functional try-in, making adjustments, send it back to the lab. The lab will rescan, redesign, CAD-CAM your final denture, and delivery. So we literally are having great success with these 3 appointment dentures. And I think the technology has a big part of that, but I think the workflow of this functional try-in is really changing the game from where we've been with wax rims and multiple try-ins and resets, because this gives us a more accurate, more predictable way to get to a good plane of occlusion in the first step and not in the second, third, or fourth step. So this excites the heck out of me, as you can tell, and I'm thrilled to death to be a part of it and get to work with great folks like Dr. Wagner.